Okay, I hope you enjoyed exploring those data sets and the different models that you can use to work with them. Right now, we're going to move on to our final tutorial, which will be not in the weeds of coding or exploiting data, but taking a bigger lens on the many different ways that machine learning can be used in fighting climate change. So here we're going to think through other applications of machine learning. You're going to get a chance to look through potential problems and data sets yourself and talk with your pod about how you see machine learning being applied to those problems. So as background, you should know that the use of machine learning and artificial intelligence in climate change adaptation, but also mitigation, is a rapidly growing field, and you can find it in various places. So you can definitely find it happening in academic research, and that will show up published in papers and journals or conferences or workshops. And this is showing up in conferences and journals that are specific to machine learning, but also in things like ecological restoration or renewable energy. Those specific fields are using data science and machine learning, and people who do machine learning research are getting more and more interested in climate change problems. You can also see this show up in industry. So there's a whole realm of startups known as climate tech, and they're getting lots of funding at the moment to use things like machine learning and artificial intelligence, along with other types of technology, to try to tackle various problems related to climate change. So if you want to learn more about specific applications of machine learning and AI to climate change problems, here's just a small example of some places you could look. So Climate Change AI is a really great hub for these kinds of things. They have a review article that goes through the many different ways that AI can be used to tackle climate change related problems. You can also look at artificial intelligence for humanitarian assistance and disaster response. As we've discussed, extreme weather events will be more common under climate change, and so this shows a lot of examples of how AI can be used to respond to disasters. You can also look at something like the Journal of Environmental Data Science. So this is looking more at environmental data using machine learning and data science approaches. And then if you want to try to find specific data sets, you can again look at the Climate Change AI website. They have a wiki that goes through many different topics related to climate change and includes some resources to data sets or papers that use machine learning for those topics. So that's something you'll get to do later in this tutorial. Driven Data is where we got our dengue fever data set, and you can look at their website for more examples of those kinds of data sets. They're not all related to climate change, but they do have some other climate-related options. Zindi is another data set hosting website that's specific to Africa. And so, again, not all of the data sets and challenges that they host there are climate change related, but certainly several of them are. Kaggle is also a very broad data science website that people from machine learning use for all different types of data sets, and they host competitions for who can build the best model for certain data sets. But again, there are going to be climate change related data sets in the Kaggle website. So when you're thinking about applying machine learning to climate change related problems, obviously there's a lot of potential there. There are many areas where if we could speed up the analysis of data or build better predictions, then they could definitely be really helpful in responding to climate change. But as we've discussed throughout these tutorials, you do have to have some caution in mind as you're doing that. So, there's the saying that if you have a hammer, everything looks like a nail, and we have to be careful to not just assume because we know the tools of machine learning and because they can be so easy to use sometimes that therefore everything's a machine learning problem. So you have to be sure in any given application that machine learning is really what's needed there. Is there a way to solve the problem that is simpler and easier and doesn't require training a machine learning model? Then you should just go with that simpler approach. You don't need to bring machine learning into every kind of problem. Now, if you do identify a problem area where machine learning could be helpful in tackling some real world issue, then even if you found a good data set to train your model, you built your model, and the model seems to be performing well, there are still going to be complications from deploying a machine learning model in the real world. So things that you need to consider are, will the data be generated in the same way? So for example, we trained our crops model, our crop identification model, using data that came from locations in Togo. But let's say we wanted to deploy that model to identify crops in different countries. it's not clear that the model would generalize. Also, would the data be coming from the same exact satellite? If we train our model with one satellite, then you can't expect it to necessarily work using a different satellite. And so that's also, you can see these issues in generalization if you're trying to deploy a model to different data generating processes or to different locations, or any other kind of difference that might occur. Did you train your model during one season and then you want to try to deploy it with satellite data from a different time of year? These are all issues where the data is not being generated the same way. The relationship between the inputs and outputs might not be the same, and therefore the model might not work as well. So because there are those potential problems when you're trying to deploy a model in the real world, you have to consider if there will be a process in place for checking the quality of the model. You kind of can't just build a model and let it run and just hope that it's performing well if you're using it to make decisions. You have to have some sort of human in the loop to be doing quality control to make sure that the model is still performing well. And then you also need to think about how will the model results actually be used. If you produce a model that can do this kind of prediction, but it's not integrated into the systems on the ground that can actually use that information, then it won't have much impact. So who's actually going to be taking the outputs of the model and using that to do something in the world? And do those people understand the way the model works or any limitations that the model might have as they're applying its outputs to the real world? In addition to those kinds of technical issues of a model being deployed in the real world, there are also a lot of ways in which the kind of recent AI machine learning boom interacts with issues about fairness and equity. So one thing to think about is the compute power needed to train machine learning models. So the models that we've worked with today and the data sets that we used are relatively small. These models can be trained fairly quickly. But if you're thinking about very large and powerful AI models like ChatGPT, those are artificial neural network models that are so large, they take supercomputers, the most advanced computing systems, to build and to train and to run these models. And so the fact that not everyone has access to those kinds of compute resources is going to limit who gets to benefit or who gets to have control over those kinds of models. You also need to think about the source of the data and to what extent the data was generated by humans, and if those humans consented to that data being used in the way that it's being used. This has come up with photo generator models that have been trained on human art, and did those artists consent to it? But it can also come up in applications to climate change. If you're using any product that humans provided, are they okay with their data being used to train a model? You also have to think about if the model is being built and deployed transparently. So do the people using the model, the people impacted by the model, do they get to understand how the model was built and how it's being used in the decision-making process? Those are kinds of things that you don't want to keep behind closed doors if you want the model to, one, be as kind of robust and accurate as possible. You want people to be able to see and assess it, and you want people to know the way in which it's interacting with things that are happening in their real life. And then who will be the most impacted by the model's use? Do you actually understand the way the model will be used and who will be impacted, or will there be kind of secondary effects that you might not have accounted for in the model's application in the real world? Relatedly to, who is the model impacting, and is it impacting different groups in the same way? Again, if you train your model on one location or one population, it might not perform as well on a different population. This is an issue of generalization, of overfitting, those kinds of things. And so if you ignore those problems and just take a model and deploy it across a diverse set of people or places, it might be treating those people or places differently and leading to increases or sustaining disparity in different groups or locations. And kind of all of these questions come down to who will be accountable for the model's behavior. So who is the person who you can go to if something negative is coming from the model? Who is keeping track of the model's quality and how it's being used? It can't be that the model is what is blamed for anything going wrong. There has to be a person who is making decisions about the model's use. So for this tutorial, you're just going to go to the Climate Change AI Wiki, and you're going to look through the different data sets and topic areas that they have available, and maybe find one that's particularly interesting to your pod, or find a few different examples that are particularly interesting to your pod. and talk through some of these ideas, kind of what type of problem, what machine learning problem might you encounter if you are working on this topic, what kind of models could you use to solve it, but then also think about these real world problems and applications. How would this actually get deployed in the real world in a way that makes a difference? And how would you think about, making sure it has a positive impact only, or how would you go about making sure that it's deployed in a fair and equitable way, or what kind of problems could arise there. So you can think about all the things that you've learned so far today and see how they would apply to a broader range of topics related to climate change mitigation and adaptation.